All right, C2 minus 2. We're going to have, this is another polyatomic ion. So each carbon has 4, and then we have to add 2 more. So we have a total of 10 electrons. Let's connect these. Well, it's probably going to look real similar to this. 2, 4, 6, 8, 10. All right, so we've done our electrons, but remember, this isn't an ion, so put it in brackets and make sure you write your charge. This notation, this is not carbon iodine, this is a Cl, so that's chlorine. So be careful there. So chlorine has 7, nitrogen has 5, oxygen has 6. So we got 18. The least electronegative one goes in the middle. In this case, it is nitrogen. Okay, let's connect them. 2, 4, 6, 8, 10, 12, 14, 16, 18. Oh. All right. Now, depending on how you do this, and again, I haven't told you why, draw me a valid Lewis structure. If you put your double bond on a different place, as long as it's valid, it will be okay. We'll talk about why one is better than another later. All right, so here we have a positive ion here. Okay, so let's count our electrons. Hydrogen has 3, oxygen has 6. Now, note this is positive. When it's positive, you lose electrons, so you need to subtract. So here, instead of having 9, subtract 1, we have 8. Hydrogen can't go in the middle. 2, 4, 6, 8. It's an ion, so note that with the brackets. Here's another ion here. Okay. Let's count up our electrons. 5, 4 times 6, and then add 3. 24 and 8, that's 32. So the easiest way to draw this is like this. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. It's a polyatomic ion. Put it in the brackets. All right, now look at this next one here. This says PCl5. Go ahead and count the electrons. Phosphorus has 5. Each chlorine has 7, so we got 40 electrons we got to deal with. Now, the least electronegative one goes in the middle. That's phosphorus. So the Cl's, remember, we're not making circles or triangles or anything like that. So these Cl's are not connected to each other. Remember now, phosphorus is one that can have an expanded octet. So it can have up to 12 electrons on its central atom. So phosphorus, if you connect these, 2, 4, 6, 8, 10, phosphorus has 10, that's okay. It can have up to 12. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. Yes, you do have to draw all the dots. This is a neutral molecule, so it does not need brackets. Now let's look at this next one. We have boron. Boron is an example of an incomplete octet. So count your electrons. Boron has 3, and then fluorine has 7, so we've got a total of 24. Now, boron is an incomplete octet, and it is actually happy with only 6 electrons. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Very good. So boron is happy with 6. ICl4. So this is not ICI4, ICl4. Iodine has 7. Chlorine also has 7. So we're up to 35. No, we're not, because we've got to add an extra electron there, so we got 36. I'd say 35 wouldn't work very well. All right, so let's go ahead and orient these. Connect them. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. All right, everybody has 8, and we still got 4 electrons to deal with. Iodine can also take an expanded octet because it is in the 3rd row or beyond, so it has an empty d orbital. It can take up to 12 electrons, so these extra 4 electrons, we're going to put them in pairs and just attach them somewhere onto the central atom. So maybe I should probably write that an I like that. Makes it a little bit easier. So it has 4 bonds and then 2 pairs. SF6. Sulfur can have 6. Fluorine has 7. So we've got a total of 48. Yes, you have to draw all the dots. Sulfur is in the 3rd row or beyond, so it has empty d orbitals. Okay, so draw them all around. Sulfur can have up to 12, and it does, so that's okay. Now, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48.